Hello and welcome to Scada123. This is the introductory video for what Scada123 is all about, which is simplified control automation and data analysis. Trying to bridge the gap between automation and IT. There's too much of a divide where you have the automation with the PLC and data coming in, and the IT guys that know how to handle the data coming, but they don't know how to get it in. This should help you solve both sides of that issue, as well as help to get off the expensive proprietary restrictions you'll find in some of those very nice but very expensive proprietary systems. This is a simple solution, nothing very expensive, and that opens up a whole variety of things you can do that were pretty much too expensive and priced out of even just trying it. A lot of this takes advantage of the open source advantages. It's inexpensive hardware, and your community support will take you to places you'll be amazed. Now, to give you a little background, some of the really old automation stuff was pretty much based on real relay logic, mechanical relays. They physically wired them up to get you your ANDs and your OR circuits and whatever other logic you wanted to do. Wasn't very pretty, but it got the job done, and at the time, that's all they had. So they had to rely on things like you'll see in the left picture here, a bunch of big buttons and some light indicators, some manual switches. Gives you interaction to kind of a blind system without much of an HMI. If you needed to see some analog values, like in the middle here, you had analog displays. Now, as well as if you wanted to record something, you got strip charts here that pretty much were just simple mechanical pens that rotated over time, and that recorded what your value was, whatever you had it hooked up to. Very old, but it worked, and at the time, like all technology, it was the best they had available. Now, some of the old PCs still on the market there that you'll see today, like Alan Bradley's MicroLogic, are pretty much the bottom end. It's a cheap, simple solution type thingy to something that's not very complex. Well, they kind of know they don't really care much about it anymore, so they gave you free downloads and for the RS Logix 500 and the RS Lynx Classic, which is their communication software. And if you want to jazz it up a little bit, make it a little bit fancier, since it is just a PLC, nothing more, you can use Visual Basic HMI from Advanced HMI. They've got a beautiful system that gives you lots of little things. And you'll see as you run through there. I've also got examples that you can look at if you want to just cut to the chase. Now, some of the other PLCs we can use, such as Automation Direct's Click PLC, those are nice simply because of two main things. Number one, they're inexpensive. They're around $100, a little bit more maybe depending upon the options and versions you get on it. Not too overly fancy, but it can do quite a fair amount, and it's a fairly new PLC that also has Modbus communications. Modbus is an open source technology that you'll see and use later. That is what gives you your communications to the PLC, that you're not locked up into any specific driver or vendor. Gives you a whole open world, and you can really do some pretty impressive stuff there. The software is free, and that Modbus interface will pretty much let you see everything that the PLC sees. Now, in addition to PLCs, there's also the Arduino Uno, which is a microcontroller. There's lots of microcontrollers that were out on the market, but the Arduino Uno really is kind of taken to a nice, cheap, inexpensive, simple, beautiful package. They've got lots of interesting modern functions like pulse width modulations, so you can control the speeds on things like DC motors. You've got 10-bit ADC analog inputs, so if you want to read in an analog value, you basically have pretty good accuracy. Now, there's other data acquisition systems out there, and they can do a better job, but they'll also cost a lot more. The Uno will cost you less than $10. For less than $10, that's pretty impressive. Now, your 10-bit, that's not that bad. Think of it this way. You've got a 5-volt, 0 to 5-volt input. You're dividing it by the 10 bits, which is 10,024. So basically your accuracy is 5 divided by 1,024. Not bad if you just want to see something that's basically within a tenth of a volt, you have greater accuracy than that. Now, another impressive thing now hitting the market is the Raspberry Pi. Well, actually, I can't say that. It's been around a long time. But the Raspberry Pi 3 has just come out in 2017. Now, the Raspberry Pi is a little bit more impressive than the Uno. The Uno is a microcontroller. It just runs a program, straightforward, does what it does, and keeps repeating it, kind of like a PLC. Raspberry Pi, on the other hand, that is a full-blown PC on a board. Now, when I say full-blown PC, I basically mean it's got the CPU processor and the motherboard type stuff that you need for any PC. Everything else is kind of extra. You want a power supply? Well, you got to get a power supply and plug it in. You'll kind of see that on the bottom of the top picture here. You got to connect up your Ethernet connection, and you got 4 USB connections. You can plug in a mouse. You can plug in a keyboard. You've got built-in Wi-Fi in version 3. You don't have to do anything there. The operating system is on an SD card. You're going to get an SD card. You've got to basically download some free software from Raspberry Pi, load it up, format it, and stick it in. A little Raspberry Pi, you'll see where about the symbol is underneath there, and then you're ready to go. You're off and running. Not too overly complex, but it takes a little bit of getting used to. As well as you might want to think about, say, a nice little enclosure to kind of put everything in. Here you see a rather industrial power supply. That is something you're going to have to think about. You will run into issues if you want to do anything with circuitry. You're going to need additional power, and just running the little cheapy, little simple 1 amp power supplies that are just enough for the Pi isn't going to help you out with your circuits. So you may want to think about that. But it is a sweet little package. Now, what does that mean? Well, one of the things you can do with it is called NodeRED. That was developed by IBM, and it is quite an impressive little thing. It's based on Node technology. Basically, your Node technology comes from the old JavaScript Node type stuff. Pretty cutting edge, good stuff. Gives you the full-blown Internet of Things, IoT type interfaces that you hear a whole lot of hype about, but most of them kind of fail simply because it's not really a web server. They either have web access IOs, which are kind of make you wonder why, and you've got your own server. You can put your own web software on there. Well, that's what the Pi does, especially with NodeRED. You got it. It's a full-blown IoT with the Pi's GPIO, general purpose interface. Its inputs and outputs, you can do some impressive stuff. Now, if you want to spend a little extra money, you can get the Opto22 input-output board that you'll see down on the left here. You've got all the adapters. You've got the Pi that you basically click onto their little chip, which then connects to their output and input boards, which is basically made up of all their distinct solid-state relays for reading stuff in or outputting values. Now, how you program NodeRED is also rather interesting because you actually program it on a browser. You are fully web enabled. So you'll program it basically with graphical programming, which kind of takes its own learning curve there. But if you ever worked with something like National Instruments LabVIEW, you'll catch on pretty quick because it's pretty much the same thing. You grab objects, you fill in information in those objects, throw them on the screen, connect them up to, say, an output, and fill in details in that output, you're done. Then what do? You create a screen and you throw that data to that screen. You'll see that on the far right. You can basically have dial displays, you got push buttons, you can see trending charts. It's got a whole lot of nice stuff there, and I'm sure they're going to expand on that later, so you can pretty much do whatever anybody else does. Now, speaking of that, this is basically all kind of built on LAMP technology. LAMP was basically the predecessor to all the Node, all the JavaScript, all the introductory web stuff from the very beginning that was based on Linux. LAMP is an acronym that stands for Linux, Apache, MySQL, PHP. That is what most of your system servers running the internet and the whole World Wide Web, that's what they're running. They're running Linux. They're usually running LAMP. This is commercial technology. This isn't just some little toy thing. It's not just some cheapy stuff. It may be free, but that doesn't mean it isn't any good. Linux has a long pedigree, and they really have gotten away from having any issues with blue screens of death. That's why it's industrial. That's why you want it. Apache's a web server. That'll run things like Drupal and Node. And that's basically what gives you your whole communication web access. Your MySQL is the database that you use. You can do pretty much whatever you want to do with the database. You can log data, you can hold that data to do process improvements, you can show that data for business intelligence, you can have that data part of a CMS for a web development like Drupal, or you can just do data analysis. Whatever you want, it's a full-blown database. And how you interface with that is generally, although you're not restricted to, but it comes with PHP, which is a built-in web programming language. Pretty cool stuff. Now I know I ran through a lot really quick, but if you go to Scada123.com, you'll see all the code examples, documentations, and links to take you all the rest of the way through there, hopefully. Thanks for watching. I hope you enjoyed this. See you in the next video. Bye-bye.